Video going. Okay. We always kind of skip over chapter 5 unless we've got some extra time for some reason. We could come back and do it later, but chapter 6, in my opinion, is more important than chapter 5. So we're going to skip it for now. And the title of this section is called Area Between Two Curves. We are going to be doing some graphing. That's why I said make sure you have a graphing calculator. But let me compare this real quick to something that we did in chapter 4. So you really don't have to write this down. I think you may have actually done something like this in your notes already. It's kind of blurry, but we did area back in chapter 4. And a lot of times they'll give you like a list of equations and they'll say find the area of the region bounded in by these functions. That's kind of what happened right here. They're not telling me where these vertical lines are exactly, and they're not really saying what that function is exactly. But to find the area under a curve, you always set up an integral from where x equals a, the left bound, all the way to where it ends on the right. A lot of times those are vertical lines. Now, when we did this in chapter 4, it was always the area between a curve and the x-axis. On all of those problems, it stopped at the x-axis. That's where it gets a little bit different in chapter 6. It's not just the area between a curve and the x-axis. It's going to be the area between two curves. So the part down here will be some other kind of weird curve. And you got to find that area bounded in the middle. So I couldn't really find a good picture of that off of the internet. So I just kind of sketched my own here. You will probably want to copy this down, and I realize you may not have all the different colors that I have up here, but that's okay. As long as you have everything labeled, it should be fine. So this is basically an example of two parabolas. Those just look like parabolas up there. The part in green, I'm calling that g of x, kind of because the word green starts with g. And then f, it's blue, that doesn't really go together. But f of x is like that parabola that is opening down. Now our job on this type of problem would be to find the area of this region bounded between those two parabolas. So what I have shaded in red right there would be the area that you are trying to find. Now here again, where it stops on the left, that is A, the lower bound, and where it stops on the right, that is B, the upper bound. Now, there's a pretty specific way to find that area. Back in chapter 4, the function that you integrated was always just the first one in the list. That was actually a question a lot of you asked me when we were reviewing for our tests. Which one do I integrate? It was always just the first one, the one that actually had something going on. Well, now you've got two functions with something going on. So there's a very specific order that you have to put them in. So this probably needs to be in your notes. To find the area of that region, you're going to integrate from A to B. Again, A is the part on the left, B is the part on the right. But it says f of x minus g of x. And I need to make sure you know exactly what that means, which function goes first and which function goes second, because it's not always going to be labeled f and g. They may all have y equals out front, so you'll have to figure out on your own which one goes first and which one goes second. So here it is. This is very, very, very important here. The function that you put first is the function that forms the top part of the shaded region. The function that forms the top part of the shaded region. That is your f of x. Even though it may not be labeled f of x, that's the function that you have to put first. And so looking at this picture here, and in particular looking at your region, the function that formed the top part, that is what we labeled f of x. So g of x, the part that you're subtracting, I'm trying to get fancy with my colors here, but g of x is always the function that forms the bottom part of the shaded region. That was the part in green on that picture above. So when you drew that picture in your notes, again, it's okay if you don't have the colors, but you need to make sure and label that is f of x. Make sure you put f of x with that, and that has to be g of x, because f forms the top minus g, which forms the bottom. So it's always top minus bottom. That's the order that you put your functions in. Okay, so pretty much today, it's going to be our job to sketch the graph and find that region that's been bounded in. And once you find the region, you can set up your integral, put the function on top minus the function on bottom, and then integrate. It should give you back some kind of number since we are talking about area. Now remember, area should always be positive. So if you get back a negative, which means the region is under the x-axis somewhere, just make it positive, and then that would be your answer. Okie doke. So our directions, I don't think they changed today. This is it for all of them. And it says, sketch the region. So I will want you to graph a little bit on your paper. Sketch the region bounded by the graphs and find the area. Sketch the region bounded by the graphs and find the area. So even though I would like for you to graph on your paper, it's going to help to kind of graph it on your calculator first, and then you can just sort of recopy everything onto your paper. Okie doke. So let's start with this one. Example 1 says y equals negative x squared plus 2. And the other function says y equals 1. Now, it's our job to sketch the region first of all, and then we'll find the area that's been bounded. Now this, I hope we don't really have to have our calculator for. You can, but this is a parabola shifted up 2 and flipped upside down. I'm just going to wing it here. Shifted up 2, flipped upside down. That means the next couple points would be right there, right there. I'm going to guess, since my other function is a horizontal line at 1, I'm thinking those points are probably enough for that graph. And then here comes y equals 1, which again is just a horizontal line at y equals 1. So, I mean, you don't have to shade this region in if you don't want to, but I'm going to do it up here just so we can all see that that little area right there is what we are trying to find. Okay, notice it doesn't say f of x and g of x. we're going to have to figure out which one goes first, which one goes second. So here comes my integral. Now A and B, looking at our region here, I'm just going to draw this here so you can see it better. The A is where the shaded region starts, and the B is the x value where it stops. And so on this problem, it's going to be from -1 to +1. The A and the B are always x values that you're looking at. Now, I'm supposed to put f of x first, which is the function that forms the top part of your shaded region. Well, the top part of our shaded region was that parabola shifted up to flipped upside down. So that needs to go in for f of x. That is our function on top. Now, we need to subtract g of x and, question, okay, we need to subtract g of x, and I will caution you that if your other function has several terms in it, you will kind of have to put parentheses around the g of x and then distribute the negative. But in this case, the function that forms the bottom part of the shaded region was just the 1. So I don't really need to put 1 in parentheses there. I'm just going to do it like that. Now I will go ahead and put dx around the whole thing since I'm integrating with respect to x. This is very exciting. Hello. Yes, I will. You're welcome. Bye. James, you're needed. I don't know what it's for, but I think you're probably coming back if you want to just head down there real quick.
No.
What? Yes.
Is it supposed to be
Squared. Yes, thanks. Oh, man, that could have been bad. Okay, so I'll catch you up here in a minute, James. I'm going to keep on going here. I should probably combine those like terms. So 2 minus 1, that's just a +1. I like to do that first. Now we should be able to integrate. And compared to the integration that we were doing at the end of chapter 4, the integration today should be much easier. I don't think you're going to have any natural logs or anything to worry about. So with this first part, I'll keep the negative, but add 1 to my power, put my new power on bottom, plus when I integrate 1 with respect to x, it'll just be x. And now I'm not going to put plus c because I have a definite integral. I've got some numbers to plug in. Now, which number do I plug in first? The 1. Now be careful when you plug in the 1 because the negative is not really going to be with it. The negative kind of stays in front while you cube the 1. I know it's not going to matter too much right here because it's just a +1, but it'll matter when we do the second part here in a minute. Now, plugging in a 1 right here, it's just going to be +1. Now, subtract what you get when you plug in the -1. So that negative stays out front while you plug in the -1 for x. All of that is over 3. I'm not going to put plus -1. I'm just going to go ahead and put -1. So simplifying this, 1 cubed is 1, but then I still have to make it negative. So this is -1/3 plus 1 minus, now I'm just going to do a little bit at a time here since there's so many negatives in the back. If I cube -1, what would I get? -1, but there's another negative right there. That turns it into a +1/3. but we will have to distribute that negative. So we've got negatives all over the place. But by the time I'm done with this, I'm taking, I'll try to squeeze this in, negative 1/3 plus 1 minus 1/3 plus 1. And so you can type this in if you want to on your calculator. That should be fine if you just kind of put those fractions in parentheses. Negative 1/3 plus 1 minus 1/3 plus 1. It gives me back like a 1.3 repeating. So I'll just stick that up here. I'll just make it 1.3, and then it is area, so I'll probably stick units squared as my label. If you kept it all as a fraction, it would be 4/3 units squared. Okie doke. It makes sense that the number is not very big because the area that you bounded in just wasn't very big. Any questions on number 1? All right, let's keep going. I think I've got 4 of them today. So number 2, y equals x squared minus 3 and y equals x minus 1. We don't really know which one is f of x, which one is g of x until we get these graphed. So if you want to type this into your calculator, you can. This should be just a parabola shifted down 3. We might need a few more points this time, so don't forget you can hit second graph to pull up your table, which has several points on there. So there's a nice point at, bless you, 0, -3. Couple more points right there at -1, -2, 1, -2. There's also a nice point, welcome back, at -2, 1, and that means another nice one at +2, 1. We can keep going a little bit if you want to. Mine might go off the graph though, so I'm just going to connect that for now. And if I need more points later, I can always graph more later. I can extend that if I need to. Now the second function is just linear. It's a line with a slope of 1 shifted down 1. So I've got a y-intercept at -1, slope of 1. I can see right there where it's going to hit that parabola. And I can see down here where it's going to hit that parabola. So we don't have to go too far. Now, as far as our shaded region, it would be right here in the middle. I'm not going to spend too much time shading it in, but it is important to see it very clearly so you can tell which function forms the top and which function forms the bottom. Which one would form the top? Yeah, it's kind of slanted, but we would still consider that the top. Now I guess I should figure out my A and my B here. The A is where the shaded region starts, so that is -1. And B is the x value where it stops, and so that would be +2. And that is correct. We want to put x -1 first, minus, now this is what I was talking about, we have to subtract the function that forms the bottom. Well, the function that forms the bottom is the entire x squared minus 3. I'm just going to use some brackets there to put all of that with the dx, but one of the most common mistakes on this type of problem, I betcha, is right here. forgetting to distribute the negative. It'll say x minus 1 minus x squared plus 3. I guess I can get rid of the brackets and just use parentheses there. So I'm going to make this look a little bit better. It's actually negative x squared plus x plus 2. Now I haven't integrated yet, but that's what I'm looking like once I get everything simplified. Okay, easy integration. Keep the negative out front. You'll have negative x cubed over 3 plus x squared over 2 plus 2x. And now I need to take it from negative 1 to positive 2. But don't forget, gotta always plug in the upper bound first. So I'll try to show all of this down here. Keep the negative in front. So this is negative 2 cubed over 3 plus, we could go ahead and actually do some of this. When I plug in a 2 right here, 2 squared is 4, so that'll turn into 4 over 2, which is just 2. And then plug in the 2 right here. 2 times 2 is 4. Now let's subtract what we get when we plug in the negative 1. Keep that negative out front. Cube the negative 1, put it over 3. Plus, be careful, with this part, we would want the entire negative 1 to be squared over 2. And then plus 2 times negative 1, that'll just make a negative 2. So, I'm going to have to write pretty little here, but here goes nothing. This is going to be negative 8 thirds plus 2 plus 4. Now, look in here at the first part in the parentheses. Negative 1 cubed is negative 1. We make it positive, but then once the minus goes into it, it turns into a minus 1/3. Okay, square a negative 1, you get positive 1, but once the minus goes to that part, it turns back into minus 1/2. And this was a negative 2, but by the time I put that minus with it, it will turn into plus 2. So this is where we cross our fingers and we hope that we get the right answer. Negative 8 divided by 3, negative 8 thirds, plus 2 plus 4, minus 1/3, minus 1/2 plus 2. That gives me 4.5. So 4.5 units squared. You can check definite integrals on a calculator. We all know that. But I would need to see how it simplifies, how it integrates, and also show some work down here when you plug in those bounds. I need to know that you actually did it too. Okie doke, any questions on that one? All right, got a couple more here. Number 3. These get a little bit easier as you go because it is kind of the same setup each time. Number 3, f of x equals 0 and f of x equals x squared minus 2x. F of x is the same as y. So y equals 0, I can go ahead and graph that part right now, which you can't see very well, but that just turns into a horizontal line at 0. Now, if the second function was just x squared minus 2, we would just shift the parabola down 2, but that's 2x, which makes it a little bit different. So I'm going to try to get some good points here from my calculator. Hit second graph if you want to see the table. So I'm thinking 1, -1. That looks to me like it's our vertex. Then we've got points at 0, 0, 2, 0. Don't do more work than you have to. Once I get those graphed and I connect them, I've already got my shaded region. It's already working out, so that is what I'm trying to find the area of. Okie doke. Now, I'm going to go ahead and set this up. I'll be integrating from A to B. A is 0 here, which I love because 0 is really easy to plug in. B is 2. Now, which function forms the top part? 0. And so I have to take that 0 and subtract the function that forms the bottom part, which is x squared minus 2x. But here again, the minus has to go to everything in those parentheses. So this is actually negative x squared plus 2x. That's what I'm going to be integrating. All right, so here it goes. Negative x cubed over 3 plus 2 times x squared over 2. I'm just leaving the 2 out front while I integrate the x. Now actually, those 2's can just drop out, which makes it a little bit easier to work with. Now it's negative x cubed over 3 plus x squared, and we're going from 0 to 2. So plugging in the 2 first, I get negative 2 cubed, which will be a negative 8 here in a second, all over 3, plus 2 squared, which is 4. Now we should subtract what we get when we plug in the 0, but that's going to be 0, that's going to be 0, so you're not even going to have to worry about the second part. And now we just need to figure out negative 8/3 plus 4. That's pretty much all we have here. Negative 8/3. Got to type it in correctly. That looks good. Plus 4. Now this one didn't actually work out to be negative. I think it has something to do with how it's butted up right against the x-axis. But if it ever turns negative, we would want to flip it around to be positive. But it is positive here. It's another 1.3 repeating. So that would be it, 1.3 units squared or 4/3 units squared. Top part minus bottom part. Any questions on that one? Okie doke. We've got one more here, and I just want to do one where there's a few more functions, couple more functions. Number 4. It says y equals 2x squared minus 3. Then y equals x plus 1. And a couple vertical lines in the back. X equals 0 and x equals 1. I'm going to graph the easy functions first. X equals 0. That should just be a vertical line at 0. You can't see that very well, but there it is. And then x equals 1. That is another vertical line, but all the way over at 1. Okay, x plus 1 should be pretty easy to graph as well. There's a y-intercept of 1 and a slope of 1. So we can go up 1, right 1, and you can take that as far out as you want. You can even go backwards, down 1, left 1. But I kind of have an idea here that since I've got those vertical lines, I probably don't need to go that far out. because the region that's going to be bounded is probably going to be bounded in between those vertical lines. Now, 2x squared, typing it in just to get some good points, minus 3. The vertex should be down at -3 on the y-axis, but I'm looking at my table for some other points. 1, -1 is a nice point. Also, -1, -1 is a nice point. And that's probably all that we need. If you want to do a couple more, they would fit up here. But watch what happens once I graph that parabola. There's a lot going on up here, but the bounded region has to touch all 4 functions. So it's going to be underneath of the x plus 1. It's going to be in between the vertical lines and sort of above the parabola, just kind of on that right-hand side. The bounded region has to touch all of the functions that are listed. This kind of looked like a bounded region too, but if you used that, it wouldn't be touching the x equals 1. It wouldn't even matter that x equals 1 is up there. So it just has to touch all 4. Okie doke. So A in this problem, I kind of covered it up, but that is 0. B is 1, and function on top is the line x plus 1 minus the function on bottom, which was the parabola, just a little part of it, but it's the 2x squared minus 3. I'm just putting brackets around all of that to put it with the dx. So distribute the negative. Again, that's quite possibly one of the most common mistakes. It'll turn into x plus 1 minus 2x squared plus 3. So combining my like terms, and I'm going to rearrange it a little bit, I'll have negative 2x squared plus x plus 4. And then all of that gets integrated with respect to x. Okay, stop me if you have any questions. I'm going to keep on going here. The -2 can stay out front, and then I integrate x squared, which is now x cubed over 3, plus, if I integrate x, it's just x squared over 2, plus integrate 4, and that turns into 4x. Now, I won't really have to worry about plugging in the 0, because everything turns into 0. All I need to do is plug in the 1. So we've got -2 times 1/3, because 1 cubed is still just 1, so 1/3, plus, this is going to turn into 1/2 plus 4. And again, you can subtract the 0 if you want, but it's not going to matter. So when I type this in, this right here is like a -2/3. So -2/3 plus 1/2 plus 4, it's like a 3.83 with the 3 repeating. I'm just going to round it off to 3.8 units squared. Okie doke. Any questions on that last one? Good stuff. Okay. So here's the assignment, and I do want to show you something pretty important about the first 4. But if you want to write it down real quick here, this is C93 from page 414. We're doing 1 to 4 and then 19 to 22.